Hello, this is Debarshi Kundu again. Today we are going to talk about points, lines, and planes. Just a note, the materials in this lecture might be very familiar to you and somewhat boring. Do be aware though that the material is essential for ensuring a good path with geometry, so please pay very close attention. We will be using the Cartesian planes for all mathematical calculations. An example of this plane is shown here in GeoGebra. The Cartesian plane has 4 sections, starting with 1 at the top right hand corner and 2 in the left hand corner. The 4 sections follow consecutively in a counterclockwise order till 4. In the first section, x and y are both positive. The second section has x negative but y positive. The third section, the x and y coordinates are both negative. Finally, the fourth section consists of points in which x is positive but y is negative. One sec. Let's just zoom in over there. Get a good look at the Cartesian plane. Okay, so what's a point? A point is a location in space. So basically, a point can be explained when we put a dot on the Cartesian plane. This point has coordinates being 3607.04308 being x, 945.94708 being y. So that's basically what a point is, a location in space. Or, in our case, a location on the Cartesian plane. A line is a series of points grouped together that never end. Notice the keyword never end. That means, in other words, it's an indefinite sequence of points. So, let's see an example of a line. An example of a line would be here. As you can see, this line never ends. It is made of a series of points, but it is indefinite. It never ends. A line segment is a portion of a line with 2 endpoints. So basically, a line segment does end. We could say that a point A to this point right here is a segment of the line. Sorry, I'm kind of playing crazy. Or right here, AG is a line segment of this entire line. Or let's just create a regular line segment. That's line segment HI. Let's just zoom in over there. So a line segment has 2 endpoints. But what happens if a line segment only had 1 endpoint? Then what is it? Is it actually a line segment? No. In fact, it's a ray. A ray is a line with only 1 endpoint. The other point continues on indefinitely. Basically, an example of this would be here, in which this point right there is the end point, and this line right here is a ray. Okay, so now that we know all that, what is a plane? We know that we've heard of what we call is a Cartesian plane, but what is a plane? A plane is a group of lines. So basically, the Cartesian plane is made of a ton of lines. What we've got here is basically a load of lines grouped together. That's all a Cartesian plane is. That's all any plane is, to be honest. And, well, I guess the professor isn't that prepared today. So, okay, now that we know that, the slope is the ratio of the vertical change to the horizontal change, aka rise over run. The slope of a line can be found by using 2 points in the line with the equation m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, 2 points are collinear if they are in the same line. Let's just see point A over here and point G over here. Point A over here and point G over here are collinear because they are on the same line. So they share collinearity. 2 points are coplanar if they are in the same plane. Now, in a way, you can think about this as, okay, we have point, let's just say point G was here in quadrant 1, and point A was in quadrant 1 also. They are now coplanar. They are in the same plane. And to be honest, all these points here are coplanar because it's in one Cartesian plane, one series or group of lines. Okay. So, now that we know that, we should also know a few important terms. First of all, we should know that 2 lines are parallel if they have the same slope. 2 lines are perpendicular if they have slope with opposite inverse, which I'm going to show you in a little while. Alright, so there are 3 ways to write equations of lines. The first is standard form. This is the most common. It goes in the format ax plus by equals c, where c divided by a is the x-intercept, or the point in which a line intersects the x-axis, and c divided by b is the y-intercept, or the point in which a line intersects the y-axis. Negative a over b is the slope of the line. An example of a standard form line would be 2x plus 3y equals 25. Let me just graph it. As you can see, we have a graph here, right here. 2x plus 3y equals 25. Alright, so now, what is the x-intercept? You'd have to do 25 divided by 2, aka c over a, in order to find the x-intercept. C over A would be 12.5. In order to find the y-intercept, you'd have to do C, which is 25, divided by 3. 25 divided by 3 equals 8 1/3, or 8.3 repeating, same thing. So now that we have found the x and y intercept, how do we find the slope of the equation? What you'd have to do is do negative a over b. So let's go back to WordPad over here. Ax plus by equals c is the standard form of a linear equation. In this equation, a is 2, 3 is b, and 25 is c. So you'd have to do negative a over b, so that would make the slope negative 2/3. So now that we know all that, we know how to use a standard form equation. The next form of an equation is called slope-intercept form. Slope-intercept form is y equals mx plus b, where m is the slope of the line and b is the y-intercept. In order to find the x-intercept, you have to substitute 0 for y. An example of a slope-intercept form equation would be y equals, we'll just do the parent function, y equals x. Let's just clear that. And now let's graph that. So y equals x. Now you might be thinking, where are the other values? Where's m and where's b? The answer is that m and b are invisible. In other words, m equals 1. This equation here, the parent function, y equals x, has m equal 1. And how do we know that? Let's just graph y equals 1x, press enter, and graph. The same exact graph. By definition, x has a slope of 1. Preset already. That is just by mathematical definition. The y-intercept is 0. In other words, the origin. The origin, by the way, is the center point in the Cartesian plane, which is right here. Let's zoom in more. Okay, zoom in more. Zoom in more. Okay. Alright. Sorry, going a little crazy today. So the next form of equation is called point-slope form, in which y minus y sub 1 equals m x minus x sub 1, where m is the slope. In order to find the x and y intercepts, you must simplify the equation into slope-intercept form. Now, the way you do that is add y1 to x1 and solve it like a regular linear equation, which you learned how to do in algebra. And if you didn't learn how to do, you should watch one of my future algebra tutorials. Okay, so now that we know all these types of equations, how do we find the distance between 2 points? That's kind of interesting. The answer is using the distance formula. To find the distance from one point to another, we use the distance formula. And that formula is basically in which d equals x sub root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Sorry, yeah, crazy. Anyways, so we now know about the distance formula. We know about point slope form, slope intercept form, standard form. We know what collinear is, coplanar. We know the definitions of lines, line segments, planes, and slopes. And now we kind of know how to use it. This will be the foundation for the rest of the tutorials in geometry. Thank you very much. This is Debarshi Kundu, and please return to my next tutorial.